we're going to look at solving this homogeneous differential equation. Now, as with other videos, other examples, I want you to pause this video, make an attempt at solving this, and then once you're finished, you can look at the solution that I have. Okay, finished? Let us see how this goes. So, with this, you cannot solve it by direct integration, nor by separating the variable. It's a homogeneous differential equation. So, let's go ahead with the method that we are going to use to solve it. Let y be equal to vx, where v and x are functions of x and y. Or it could be constants, no, functions of x and y, right? Now, dy by dx equals your whole v as it is times differentiate x with respect to x, that's 1, plus your whole x as it is times differentiate v with respect to x. Okay, good. Now, we have our dy by dx here and our dy by dx here. Let's transpose that one up top. We have dy by dx equal 2x plus y over 2y minus x. Alright. So, that's what we have. Let's equate them now. We have, let's put this one first since it has the dv by dx in it. V plus x dv by dx is equal to 2x plus y over 2y minus x. Oh, I'll put plus minus x. But now remember, y is equal to vx. So this y, we change it to vx. And this y, we change it to vx. Notice here, we could factorize the x, We could factor out the x. So we have x outside the bracket, 2 plus v over x outside the bracket, 2v minus 1. And x cancel x, you see that? So, what we have is v plus x dv by dx is equal to 2 plus v over 2v minus 1. Now, what we aim to do is have on the left hand side a function of v dv equal on the right hand side a function of x dx, and we integrate them. Let's see what's going to happen now. Let's subtract this v from both sides. So we have x dv by dx is equal to 2 plus v over 2v minus 1 minus v. Okay. Now, let's do some fractions. This is v over 1. Let's use common denominators. Multiply the 1 by 2v minus 1 and multiply this v by 2v minus 1. Common denominators. So we could just erase this 1 times and have this. So, what we have here now is x dv by dx is equal to, this will be all of this over 2v minus 1. So it's 2 plus v minus, it's negative v times 2v, which is going to give you a negative 2v squared. Then negative v times negative 1 will be a plus 1. Alright. So, plus v. Negative v times negative 1 give you a positive v. Notice this v plus this v will give you 2v, right? So let's use the little space over here and write 2v plus 2 minus 2v squared, and that is over 2v minus 1. Okay, and remember now, if you didn't know how to start it, once you see me start and go to step 2, it would be good if you pause, then continue from there to step 3 and so on and so forth. Alright? Or at any point you were stuck, if you see me reach that point and go to the next step, then you can pause it and take over from there and continue working. Remember, you learn by doing. Right? So now, multiply both sides by 2v minus 1. You have x dv by dx times 2v minus 1 is equal to 2v plus 2 minus 2v squared. Let's divide both sides by 2v plus 2 minus 2v squared. You have 2v plus 2 minus 2v squared. This over 2v plus 2 minus 2v squared. And multiply by dx. Multiply by dx. Alright? I'm erasing and rewriting because we'll soon reach where we cannot scroll down anymore, right? We use up the space. This will cancel. So that is gone. And then divide by x. When you divide by x, it cancels on the left. I have 1 over x on the right. Alright, so let's move the dx closer to here. So here now, the dv. So we have 2v minus 1 over 2v plus 2 minus 2v squared dv equals 1 over x dx. So we integrate now. Integrate both sides. Alright, on the right hand side, when you integrate 1 over x dx, you get ln x plus c. Let's look at what will happen on the left hand side. Well, no. Alright, let's rewrite this. What we have is the integral of 2v minus 1 over, let's put the highest power first, negative 2v squared plus 2v plus 2 dv. Now, let's try integration by substitution. Here, I was doing some work previously down here. Let's erase these to make space. So here, let u be equal to negative 2v squared plus 2v plus 2. Then du by dv would be 2 2's negative 4v plus 2. So dv would be du over negative 4v plus 2. Alright. So what we have is the integral of 2v minus 1 over negative 4v plus 2 du. Right? Now, here. Oh, let me redo that. It is 2v minus 1 over this here is u. So it is over u dv. But instead of dv, we put this, right? So what we have here is du over negative 4v plus 2. Now here, what we have, let's scroll up, let's erase the previous work there. What we have here, let's put E equal to remind us that there is something else over the right hand side. Alright, so here, this is the integral of 2v minus 1 over u du over, let's factorize this. This would be negative 2, let's put negative 2 here. Negative 2 into negative 4v goes 2v. Negative 2 into negative 2 goes 1 minus 1. Okay, so these cancel. So what we have is negative a half integral of 1 over u du. Now, this is going to be negative half ln u. We won't put any plus c on the left hand side because we already have it on the right. So what we have, the integral is negative half ln u, but what was u again? U was negative 2v squared plus 2v plus 2. Negative 2v squared plus 2v plus 2. Negative 2v squared plus 2v plus 2. And what was this equal to again? Ln x plus c. Can't scroll down anymore. Run out of space vertically. Ln x plus c. Alright, so let's just draw a line up and continue working on the right hand side. So I'm going to try and remember all of this and rewrite it, I will make a copy of it. Alright, group them and put it up here. Alright, so we continue working from this. Alright. So here now, look at this. This is negative half ln something equal to ln c, ln x plus c. C is a constant and it can be the ln of another constant. Let's call this c ln a. Let's call it that and get rid of the c. So this now, if you remember your rules of indices and logarithms, this would be ln negative 2v squared plus 2v plus 2 raised to the power of negative half. Alright? Equal ln of ax. Remember that? Ln x plus ln a is the same as ln ax. Just like how 2 times 3 is 6 and ln 2 plus ln 3, which is that, is the same as ln 2 times 3, which is ln 6. Same thing, right? And so on and so forth. So ln x plus ln a is the same as ln xa or ax. Now we can say e to the power of ln negative 2v squared plus 2v plus 2 raised to the power of negative half is equal to e to the power of ln ax. Now you have to remember the other rule. E to the ln of a number is equal to that same number. An example would be like, say, e to the ln 5, 6, whatever number it is, right? So e raised to the power of, let's put open bracket, ln what now? ln 6 close bracket equal, and you get 6. Any number you try, it will work. The exponent e to the power of and the ln, they cancel each other, leaving the number undisturbed, right? So what we have here is that negative 2v squared plus 2v plus 2 to the negative half is the same as ax, right? Now, here, we can, oh, by the way, remember y is equal to vx. So, v is equal to y over x. So we can change the v back. So we have negative 2 y over x, y squared over x squared, plus 2 y over x plus 2 raised to the power of negative half is equal to ax. Now, here, what this is saying is that 1 over negative 2 y squared over x squared plus 2y over x plus 2 is equal to, and all of that, the square root of all of that, say to the power of a half, is equal to ax. Now, if we square this, right, what we'll get is just this being equal to ax squared. But a is a constant, and when you square a, you get another constant. Call the new constant b. Right? Now, here, what can you say about this now? Suppose we multiply both sides by all of this. What we would have is 1 is equal to bx squared times negative 2 y squared over x squared plus 2y over x plus 2, right? We just want to neat up the thing, right? That's what we're doing. Now, let us consider this. This is over 1. Let's divide both sides by b and call it, well, we use C already, call it a new constant. D is equal to x squared. You see this 2 can be taken out. Negative 2. So we have y squared minus y plus 1. This is over x squared over x over 1. Alright. Run out of space again. Let us continue over this side. So, what we have is d equal to negative 2x squared. D equal negative 2x squared. Then after that, y squared over x squared. So we have y squared over x squared minus y over x plus 1 over 1. Minus y over x plus 1 over 1. What can we do with this now? Suppose we multiply out the bracket now. So d is equal to negative 2 times. Let's multiply by x squared. This would be x squared y squared over x squared minus x squared y over x plus x squared. X squared cancel x squared. X into x1, x into x squared goes x. So let's divide by -2. We got a new constant, call it e, equal y squared plus, no, minus xy plus x squared. That's how much neater way of putting it. Alright. So what we have is, let's put the x squared first. X squared minus xy plus y squared equal e. By the way, tell me something. So I put this as x plus y, x minus, no, x minus y. Just wondering. X minus y. What would happen? This is x squared minus xy plus y squared. Okay, yes, that's it, you know. It turns out to be x minus y equals e. Well, that's what I got, but you get the idea, right? If you're in exam, you wouldn't have a lot of time to be neating up everything, right? I think in exam purpose, if you're running out of time, you could pause at this point and move on, because it shows that you know what you're doing. You showed your skill. But if it is a take-home assignment or so, then you would want to neat it up until you reach something like this point or so. Alright, so I'll see you in the next video.